Hello everybody, Radical Dude here, and today we are going to learn about Pythagorean identities. Pythagorean identities. Okay, so very simply we have to learn something from the beginning. Something that you should already know that you have to take to the picnic, right? It's called theta, y, x, and r. I want you to be able to write a few equations just with this triangle right here. Make it a right triangle. There you go. This is the stuff, the prerequisite you need for the Pythagorean identity. First of all, the first thing you can do is basically the Pythagorean theorem. That's nice and simple from the three sides of this right triangle. Then you need to know some of the basic trig functions that we've discussed before. Sine theta is y over r. Cosine theta is x over r. And tangent theta is y over x. These are some of the basics that you need to know. So what mathematicians do is they play around with things. Play around, see if we can try different setups, plugins and stuff. Basically they do it because they have no friends. That's basically why mathematicians are doing this. So what I'm going to do is I'm going to solve for y and solve for x and then plug it in there. So if I solve for y over here, just put this over 1, put this over 1. I just need these two. I don't need this formula here. So when I cross multiply, I get y equals r sine theta. And when I cross multiply here, I get x equals r cosine theta. So now what I'm going to do is I'm going to plug this into the Pythagorean theorem. So, here's the Pythagorean theorem, and I'm going to plug it in. What we decided x was r cosine theta, and we're going to square it. And y was r sine theta. We're going to square it, and that's that. You square this, okay? It means r cosine theta times r cosine theta. So when you multiply r cosine theta times r cosine theta, you get r squared cosine squared theta. Okay? Not cosine theta squared. The difference is this is cosine theta times theta. Hey, look at that. Whee! Looks like my ex-wife. Instead, it's cosine squared theta is cosine theta times cosine theta. See the difference? Okay. Except, of course, when my ex-wife sees me, it's more like that she looks like. Okay, let me get rid of this part here and plug it in. So it's r squared cosine squared theta plus, on the same principle, r squared sine squared theta equals r squared. Now, what to do? Well, we can play around. Let's get rid of the r squares. So, I get rid of that r squares. And what happens? I'm left with cosine squared theta plus sine squared theta equals 1. That is one of the Pythagorean identities. Very important. They put the sine squared usually in front, but it doesn't matter because addition is commutative. That is one of the Pythagorean identities. let's play around with this. Sine squared theta and cosine squared theta equals 1. Well, what if I were to divide by, well, I can divide by anything as long as it's the same throughout the whole thing. But let's just say if I divided by sine. If I divide this by sine squared theta, this by sine squared theta, and this by sine squared theta, what do I have? Well, this cancels, and I'm left with 1. Cosine squared theta over sine squared theta is the reciprocal of sine squared theta over cosine squared theta. Sine over cosine is tangent. The reciprocal of the tangent function is cotangent. So this is cotangent squared theta. And 1 over sine squared theta, the reciprocal function, is cosecant squared theta. So that is another Pythagorean identity. It's 1 plus cotangent squared theta equals cosecant squared theta. So that's 2. Let's go back to our original, and this time let's divide by cosine squared theta. So I divide this by cosine squared theta, this by cosine squared theta, and this by cosine squared theta. Look what happened. Sine over cosine is tangent. So this is tangent squared theta. Well, I got a message. Cosine squared theta over cosine squared theta equals 1. And 1 over cosine squared theta is equal to, what do you read for the picnic? It's equal to secant squared theta. So there's the third one. Tangent squared theta plus 1 equals secant squared theta. Tangent squared theta plus 1 equals secant squared theta. So these are the Pythagorean identities of trigonometry. Hope you radical dude, and I hope you learned something.